So on Monday, we were in 4-7, my favorite section. So what I actually decided to do for 4-7 is that I'm going to pare the homework down for that. So I want to show you how to do 4-7, but we're not going to actually do the homework for it. So, you know, you can listen, but listen and learn it while I'm talking. And then we're going to kind of skip over the homework for that so we can get into the last section. Okay, so in 4-7, give me just 1 second here. Okay, yeah. So in 4-7, what we talked about was another method for solving quadratic equations because we didn't have enough methods before, right? And one of the things we talked about was using this idea of the perfect square. So we had some examples that we did in class. I don't think we did number 2. So let me do number 2 really, really fast to just kind of remind people of what that means by solving by the perfect square. So this is number 2 just on your paper. So if we had x squared minus 10x plus 10x, we need x there, plus 25 equals 1. Okay, and we want to factor x squared minus 10x plus 25. There should be like alarm bells going off in your brain because 25 is a perfect square. So more than likely, we're going to use 5 to factor. Okay, and to make a positive 25, we can do a negative 5 and a negative 5. I'm just forgetting all my x's today. And that equals 1. All right, so we can say that x minus 5 squared equals 1 squared. And then we can actually take the square root of both sides, and we end up with x minus 5 equals plus or minus 1. And so then we know that x equals 5 plus or minus 1. So x could be 6 or x could be 4. So that I do want you to do. I'm going to have you do the homework for that. The second part is called completing the square. I'm going to show it to you, but I think I'm going to not assign the homework for it. Unless you really want to do it, then you're welcome to do it. All right, so the second part is called completing the square. And this is how it works. Ugh, don't want that to be like that, okay. So if we have example number 5 here, we have x squared plus 4x plus 6x plus 4. I can totally read today. Plus 4 equals 0. Okay. And we want to solve it by completing the square. All right. So we talked a little bit about this on Monday. So we can, if we don't know what this number is, we can make this equation into a perfect square by using the middle term. So if we take whatever is in the middle, we call that b, divide it by 2 and square it. Okay, so let's kind of ignore that we have a plus 4 here. So if we have x squared plus 6x, okay, and then I look at 6 and I do 6 divided by 2 squared. So 6 divided by 2 is 3, squared is 9. So if my last number was 9, then this would be a perfect square. And I could say that this is x plus 3 squared. That's what I'm hoping for, right? Well, how do I turn plus 4 into plus 9? So the difference between having, because what I really have is plus 4, right? But what I want to have is plus 9. So what I could do is I could add 5 to both sides of my equation. Because as long as I do the same thing to both sides, I'm good. So if I add 5 to both sides of my equation, this becomes the quadratic I want, x squared plus 6x plus 9, right? Because 4 plus 5 is 9. But my other side becomes 5. So this factors to x plus 3 squared, and this says equals 5. Okay, so then I can do the same thing I did in my quick review up here. I can take the square root of both sides, and I know x plus 3 equals plus or minus the square root of 5, or x equals -3 plus or minus the square root of 5. So you can see where this method, this is the answer. You can see where the method works. I just think that there's other better methods for doing that kind of problem. Does that make sense? Okay. Okay, so let me grab my book super fast and tell you which ones to do and not to do. So give me like 1 minute. I don't have my book. Okay. So in 4.7, you haven't done all your homework yet, have you, Connor? Okay. Okay, good. So I want to make sure you didn't you were ahead and you're like, oh, I already did that. All right, so in 4.7, basically I just want you to do, let me double check here before I tell you. Three through 11 odd. Actually, how about 3 through 13? Actually, do 3 through 13 odd. Sorry. 4.7. Yep, 4.7. Yep. Yep. Because like I said, I'll be totally honest with you. I think it's good to know that that method exists and it works, when it's nice and easy. But when you get down here and you're using this, there's better methods for doing that. Okay. Finally to the method that always works. So what I'm going to do, Connor, is well, actually, you're going to just love this. I think I'm actually going to skip the method that finally works and save that for Monday, because the last little section that we do is all graphing. So it's a quick, easy section in the back, 4.9, and it's on Desmos. And then that way on Monday, we can just spend a lot of time talking about the method that works. So if you really want to know what it is, I can show it to you now. You're dying in suspense, but it's quadratic equation. Yep. Have you done that before? All right. So you already know. All right. So that's what we'll do on Monday. We're just going to do 4.9 really fast. I think it'll honestly take us, 10 minutes maybe, and then we'll be done with the stuff today. So 4.8 or 4.9, 4.8 we'll go over Monday. 4.9 is solving and graphing quadratic inequalities. All right, so we started the section 4.1 with graphing and we end with graphing. Comes full circle. But when we add in 4.9, the kind of the twist is that we have inequalities with our quadratics. So if you remember, quadratics, good review. Whenever you graph a quadratic equation, you get a parabola, right? So in one of my many tabs here, let's pull up Desmos. Okay, so the standard kind of parabola is y equals x. Okay, so this is kind of the standard parabola, if we wanted to solve this for when does x squared equal 0, it would be right here at this point where it hits the x-axis, right? And I think we did a lot of work with this. And for any of our methods, remember, and I should have done this before, if you're ever solving a quadratic equation, it's always an option to graph it and find where it intersects. So flipping back a little, the problem that we just did was, sorry for the paper shuffling. My headphones are not working, so you're getting probably a lot of extra noise. So the problem that we just did, that we solved, right, was x squared, not yx, x squared minus 10x plus 25 equals 1. Okay, and when you type it in, that doesn't actually, well, it does give you the answer, but it doesn't actually give you the parabola. So what you're actually looking for is, this is our parabola, x squared minus 10x equals 25. And we want to find out, when does that equal 1? Okay, so it equals 1 when x equals 4 and y equals 6. So I think it's just a good review to always remember, you can graph it and you can check your work. So even that complex, crazy one where we have square roots and all that stuff, you can still graph it and you can get the points. You're just going to get a decimal. So in 4-9, we're going to take that idea, but we're going to say, instead of, let's see. We're going to take that idea, sorry, and we're going to graph inequalities. So if I wanted to know, where is y less than x squared? Okay, so what values is y less than x squared? What you're basically doing is, and if you use Desmos, it does it for you. But if you don't have Desmos, you're going to get your graph, right? And so we want to know, when is y less than x squared? So what you can do to figure this out is to pick a value and figure out where my shading goes. Okay, so I have Desmos, so, and you're using Desmos, so it's not that big a deal. But if you don't have Desmos, how do I figure out where to shade my inequality? So then you just pick a random value that's pretty easy to calculate and you figure it out. So this point here is at x equals 2, y equals 0. And what I'm trying to figure out is, when is y less than x squared? Okay, so if x equals 2 and y equals 0, is 2 squared greater than 0, or is 0 less than 4? Yes, that's true. So that means this point is true, and that means that my shading would go this way. So that's how you figure out, if you don't have a graphing tool, if you just are able to graph the parabola, then you don't have a graphing tool, then you figure out the shading that way. So there we go, right? All right, and the actual problem was, what happens if y is less than negative x squared? So remember, a negative just flips your parabola the other way. And so if we graph that, we get actually shaded on the inside. Okay. All right. So the other ones are really easy. So y is less than, I'm just going right off your sheet here. So we have 2, 3, and 4 are just kind of interesting graphs. It's the hardest part of them is typing them in. So let's just kind of see if we have y is greater than, negative 2x squared. So we know the parabola is going to open down. Plus 9x minus 4. Okay, so that basically means, in order for this inequality to be true, we need to pick any value that is outside the shaded region. So it can't be one that's right on here. This is not, anything along the dotted line is not valid because we don't have less than or equal to. And my favorite point happens to be on here, which is 0, 0. So if I plug 0, 0 in here, 0 is greater than -4. So I know that Desmos actually did a good job graphing it. Not that I had any doubt, but you know, it's kind of what it means. So it's not just plugging it in, it's understanding what it means behind it. 3 and 4 are kind of cool because we actually get to intersect two parabolas. So we might actually make something a little bit pretty here. So we have y is greater than or equal to 2x squared. And we have that y is less than -x squared plus 1. Okay, so then if I were going to say, and I have and there, so number 3 says I have y is greater than 2x squared and y is less than -x squared plus 1. So where these two intersect, if I was going to present the values that are true for both of these, is I would take my pen and I would draw something that looks like this. A dotted line along here, right? And then a solid line down here. And then a shaded area right in here. So it's basically the values that are right inside this little area that are true for both equations. All right, and then the last two actually kind of get to where it's useful. So solve by graphing. So we actually like to solve things by graphing, right? So this one says that we have, I kind of want to write on here, so close that. All right, so solve by graphing. X squared plus 8x is less than or equal to -7. Okay, so we kind of have two choices how you want to graph this. One is we can leave it like it is and kind of think about what areas would be on the graph. The other one that makes more sense to me is I like to flip this and say that this could also be x squared plus 8x. And then I like to make it equal, less than or equal to 0, because that just makes it easier in my brain. So I like to bring the 7 to the other side and have x squared plus 8x plus 7 is less than or equal to 0. So for me in my brain, that just kind of works better for graphing and kind of figuring out where things go. So when I go over to Desmos to graph it, I have x squared plus 8x plus 7. Whoa, I can't even see my parabola. I'm way too zoomed in. There we go. Okay, and I want to know when is that less than or equal to 0? So I want to know basically when is that less than or equal to 0? Less than or equal to 0. So actually, I don't like how you can type that in Desmos and it does that. It shifts your parabola. So I want to know when does that less than or equal to 0? So the values that would make this less than or equal to 0 are going to be the ones that are down in here, in this area. And my favorite point isn't in there. That makes me sad. So the values that make it less than or equal to 0 would be -7 and -1. Okay. So if we would have stuck with the original equation, Connor, if we would have stuck with x squared plus 8x, okay, and then we would have said that our y is less than or equal to -7, okay, so you would see that that point is at -7 and -1, just like our intersection points here were at -7 and -1. So there's just two ways of graphing the same thing, basically. Whatever way makes more sense to you. Does that make sense? The two differences? Okay. All right. So you can either set it equal to 0, which in my brain, I don't know. I just think setting equals to 0 is just what I'm used to. But if you're comfortable with leaving it like that, you'll end up in the same place. It's just that, different intersection point. And it's like an optical illusion because this point and this point both don't look like they're at -7. I think it's because the way the numbers are written in the lines, to me, they look like this one's further over on the coordinate plane. So I was looking at it for a second like, oh, that's weird. So that's that. That's all I have for today. Unless you want to see another example, but I don't think they're too difficult. I mean, the hardest part of this section is probably printing out the graph paper to graph everything on. All right, does that sound good? All right, good deal. Well, thanks for connecting on today. I hope you have a good weekend. All right, talk to you later. Bye.